Okay. Oh, well, I'm Tristan Rawlence. I work for Doc here in Nelson. And this afternoon I'm going to merge my two talks together and sort of attempt to spin it into one coherent yarn. And I've sort of going to attempt to try and weave together what we've learnt over the past few years in our program and part of this program, and also what's been presented over the last few days, and really show how all this learning has guided what we're up to in the National Predator Control Program, which I will refer to from now on as NPCP. So just to sort of recap, with a bit of theory and I guess the ecological context of where I'm at, and I'm going to explain these charts because there's going to be a few of them over the next wee while. And I want you guys to sort of get a feel for what they are because they tend to get a little bit more complicated. So we've got the solid red line. I'll just try and get my pointer going. This one here, which is rats. And then we've got this concept of damage threshold, which is this dotty red line. And that's that idea that sort of Josh and Jason presented earlier, where when we get to the end of mast periods or rodents drop out in the system, that if you've got elevated stoat levels, they get quite hungry and do prey switching. We've also got a few other things that we work with, which is a delta T prediction, which Adrian talked about yesterday, and that's available to us in about March or April of a pre-mast year. And then a few months later in November, we get the flowering of beech trees. And then the seed starts to fall off the trees kind of in February, March of the mast year. And so what typically happens in sort of high elevation beech forests is rats are quite low through the pre-mast year. They increase as the seed becomes available. And then the stoats have a pretty good breeding season where they get a lot of kits out of their nests, and they sort of decline as rodents disappear out of the system. And that damage threshold, I guess, is it's where we see those higher rates of predations on things like Theo, Kia, Takahe, and Mohua in those post-mast years. So the way the National Predator Control Program used to work was we tackled masts head on. So we had the beech mast, and I'm going to introduce a couple new concepts in this one. So we've got this green dotted line, which is the predicted rat tracking, and that's what would have happened to rats had we not done any management at all. So that's kind of a non-treatment situation. And so what we used to do is we used to do the 1080 operation in the spring of the mast year, which is about here. And that was just before rats peaked. And the idea of that was that we would get predator suppression in just before all the birds nested. Now, when those operations didn't go so well, not only did we get a poor rat kill where we didn't reduce the rat abundance that low, there was also still quite a bit of seed around. And so rats could rebound, and they generally did that in time for the stoats to still have a fairly good litter size. So that's kind of where we were working, I guess, up until 2021 was the approach. And it did deliver on a lot of occasions, but it was more likely to fail in terms of a rat kill. And so we sort of have this feeling that we weren't really achieving outcomes for birds as well as we could have. So we've really learned a lesson there, which is to avoid the food glut. So our 1080 operations were more likely to fail when we applied poison during that food glut period. So if we're going to avoid the food glut, we have to make some decisions about whether we have a 1080 operation before or after the food glut. We've coined the operation before food gluts as a nip it in the bud operation. And so here's a bit of theory on how that might work. So if we look at this top left square here, this is a sort of back of the envelope calculation where I've sort of stolen some figures off the Lake Alabaster study on tracking rates and densities, and sort of come up with a flowering rat tracking rate in a 100 hectare block of about 2%, and that sort of equates to, I guess, for the sake of this, I'll say 100 hectare block, which is 15 rats in 100 hectares. Now, if these rats in this block here go through the beach mast and grow at the maximum rate that we've seen them grow at and over mast periods, we'd be looking at sort of about 1,500 rats in that 100 hectare block at the end of the mast period. And that's about 80 to 100% tracking. So that's this bottom left square. Now, if we were to do an operation at flowering, or just before flowering, ideally, and we managed to achieve the same kill rate that we'd normally get, which is sort of 99 to 100%, then we'd expect to get the rat population down to about 1 rat per 100 hectares, which is this one here. And some clever people in the audience will wonder, well, if you've only got 1 rat there, it's not going to breed. But obviously this 100 hectare block is joined by lots of other ones. So these 2 rats in the adjoining 100 hectare blocks meet up. And if they grow at their maximum rate through the mast period, we're going to end up with about 100 rats in 100 hectares. And that's roughly about a 10% tracking rate. And so a 10% tracking rate is way below any of the damage thresholds that we sort of work with on the mainland. And so we'd be pretty happy if that was our peak tracking rate over a mast period. Okay, so next slide. So that's all the theory, but if this was true and we could just deliver nip-it-in-the-bud operations and we reduce rats to a level where there's never enough of them to build up to damaging levels, then the approach of just doing a 1080 drop before flowering might be a valid approach. And while this approach is likely to work at some sites, you know, like our upland beech forests, where they're pretty lean in intermast periods, there's a whole pile of things that spoil this approach for us in other forest types and block sizes. So the reason for a single nip-it-in-the-bud operation not delivering what we need is things like I just talked about, smaller block sizes where reinvasion is a significant driver of population increases. And we have lots of large exclusions in 1080 operations as well, so we'd have a reinvasion out of those areas. We also expect that in diverse productive forests, like some of these North Island mixed podocarp hardwood forests, that we won't ever achieve rat suppression to a level where this approach would work. And that's due to food presumably being available more of the time, which would lead to more rats surviving at the time of our operation. Now, there's always also a bit of an elephant in the room here, which is mice. Now, mice also increase in mast years as a result of beech seed. And hang on, yep. If mice increase through that mast period, like we've got on this dotted blue line here, we're still going to end up with a larger litter size for stoats in the spring of the food gut year because they're quite happy to feed on mice as well. So we don't expect to control rats and mice through the mast period with a single nip-it-in-the-bud operation. And if this occurs, or when this occurs, it's going to lead to a situation here where we still get a good breeding of stoats and it's still above the damage threshold for a long period of time after the mast. So we want to avoid that happening. So if money was not a limiting factor, we end up with, and I swear this is the most horrible complicating chart ever, where we've got a nip-it-in-the-bud operation over here. We've got the beech being available here. We've got our damage threshold through here. We've got the mice going apeshit. We've got the rats recovering. We've got our projected rat tracking. And then we've still got a good breeding of stoats. And if we cane it immediately post-germination with a second 1080 operation, in theory, we can avoid most populations pushing above the damage threshold. Now, this would be a pretty good approach to take, but there's no way we can afford to do this everywhere. But for our sites where we're trying to protect rat-sensitive species, this is probably a good way to be. So our lesson here is that one pulse of rat control isn't always enough. Now, as we can't afford to do 2 operations everywhere, nor do we need to, because a lot of the sites we're at, we're protecting stoat-sensitive species first and foremost. So to investigate this, we're going to have a bit of a more realistic looking seasonal stoat abundance, which is this black line, which has a breeding every, or an emergence of kits every November through the pre-mast period, and then a peak one through the mast. And you can kind of see that if we didn't do any management, which is the case on this slide, then we'd have quite a long period after the mast where stoats gradually decline and do a lot of damage to our stoat-sensitive species. So it's a long period of time above the damage threshold. Now, in our office, there's been a heck of a lot of discussion about whether it would be better for these stoat-driven 1080 operations where we're primarily protecting stoat-sensitive species, whether to go pre or post. And while there's arguments for both approaches, based on the points I put forward before about the mice, we think it's best to go after with a post-germination operation. And we kind of expect things to go a bit like this, which is stoats have a pretty good breeding season in the spring of the mast year, and then they have a short period of time here above the damage threshold, and then we do a post-germination 1080 operation to get them back down to low levels. Now, it might be reasonable to ask why we're not doing that operation immediately after the food glut, but kits dispersing following a good breeding season tend to run around for quite a while, and so we want to be targeting those operations in sort of April, May, when they're settling down into their new home ranges. Otherwise, our blocks are likely to get re-invaded straight away. So our lesson here is stoats will still breed well in the mast year, even with a nip it in the bud operation due to abundant mice. So it's all very South Island centric. So what about forests that are not dominated by beech? And to be honest, this is where we have the most to learn. These diverse forests have all sorts of seasonal pulses of food, as well as masting species such as rimu, hinaka, hikatea, and often beech as well. We don't have the same level of understanding about these ecosystems. But what we do know is the same mechanisms that result in poor kills for rats in South Island beech forests are likely to be contributing to poor kills in these forests. So that means if we've got growing rodent populations with abundant food, our 1080 operations are unlikely to work very well at all. So this is the situation that might happen if we ignored masts in these forests and timed our operations at the wrong time. So we've got the rats tracking along at a higher base rate, that's often 30 to 40%. They start to increase. We do a 1080 operation. We get a poor kill. They immediately recover. Stoats still have a good breeding season. And we end up with quite a lot of time above a damage threshold, which is not going to be good for the birds we're trying to protect. Therefore, we're sort of taking a different approach here, which is where we want to be avoiding doing operations in these forests when there's a food glut. And we need to be investing in research to identify at what time rats and mice are hungry. But in the meantime, our approach is mast avoidance. So if we have a mast avoiding approach, it might look something like this. We deliver a 1080 operation in the post-mast period. And that arrow there should just say mast, not beech mast, I'm sorry. So how are we going to do this? We are going to use delta T to predict the masting of beech trees, but it's worth noting that the original delta T models included other species such as Hina and Hikatea. Adrian pointed out yesterday that there's a lack of synchronicity in a lot of these species, but I reckon synchronicity appears to increase with the magnitude of the mast, and I'm happy to have a chat about that because I'd like to hear what other people think. So our approach is when we predict high magnitude mast events, these are the years we want to avoid delivering operations in these forests. And what that boils down to is a one operation strategy where we avoid masts and hopefully ensures the best rodent kills that we could hope for, and therefore a good secondary kill of mustelids. Operationally, this works quite well for NPCP as we're actually usually pretty busy in those big high magnitude mast years and a beach mast response. So our lesson here is avoid aerial control during high magnitude mast years in diverse masting forests. Now, I promise that's the end of all horrible charts, so hopefully you guys endured that. And we'll move on to some pretty bright coloured maps. So the concepts I've outlined with those charts have resulted in 8 management prescriptions for managing pests with aerial 1080. These are based around forest type, altitude, and the target pest species and the duration of suppression required to benefit the native species present at a site. So here's some forest types we've used to base our management prescriptions on. They are simplified versions of the old New Zealand Forest Service forest covers, I guess. And these management prescriptions that we've come up with range from the 2 1080 operations per mast with the nippet in the bud and the post-germination that I've outlined, through to 1 operation every 6 years for possum control. They also include operations with supplementary ground control. And it's in these prescriptions where we've addressed rat bounce. Rat bounce is one of the most problematic things for us to deal with in NPCP. And we're also unsure if it's confounded with our old timing of delivering operations during the food glut. What we do know about rat bounce is there was a strong effect of altitude, and that's also likely affected by forest type, which is also confounded with altitude. So unfortunately, we're temporarily waving the right flag on rats in low elevation and diverse forests with 1080 alone, while we figure out if our new timings reduce the prevalence of rat bounce. So the lesson here for the program is rat bounce is more pronounced at lower elevations. And we've got our first change in the NPCP program, which is management prescriptions are tuned for forest type, elevation, and target pests. So now that we have our prescriptions sorted, we have to figure out what we can afford to do and where. So Graham Elliott and Amy Hawcroft led the prioritisation work for NPCP, and Graham's given me a wee blurb here because he's sick of talking. And this is how the prioritisation works. So every site or operation gets a score based on 3 things: the condition of the forest, which is the previous management, and I guess that's also a condition of the bird populations there, the forest vulnerability to possums, the species that are in those forests, so species that are vulnerable to rats, mustelids, and possums, and they get a score which is it's their threat rank times their population size times their rate of decline. A bunch of experts in DOC and further abroad have also identified a suite of key species for which, well, actually, we've identified the key species for which NPCP is the main tool, and a bunch of experts have identified the sites where these key species hold the kind of highest value populations. Next up, each site or operation gets a prescription and an annual cost associated to it. And then there's some fancy linear programming back blocks trickery, which Graham will answer questions on happily, which optimizes the choice of sites to maximize the scores. It includes at least 1 key site for each key species in the program and spends all of NPCP's $26 million pest control budget. And what we ended up with after all of that is this lovely map with a bunch of operations. Now, as a result of this, it's turned out that we can't afford to manage every site we have on the books, and definitely not all the PCL that DOC's administered to look after. So rather than doing a bad job everywhere, we've made some really tough calls, but as a result, we've become really clear on why we're at each site, what we're there to achieve. And all of this equates to about 1.8 million hectares of PCL under some kind of management. So the change here is NPCP is focused on the quality of predator control, not the quantity of hectares under control. So on this map here, this is the same prioritised sites, but we've been chatting lots about rats over the last few days, so that these sites highlighted in yellow are the sites where NPCP is delivering sustained rat control. In the North Island, this is mostly only in parts of the blocks using supplementary ground-based control, which is often delivered by the community, not by NPCP. In order to be prioritised for this level of suppression at these sites, the species that live at these sites are kōkako, short-tailed bats, and long-tailed bats. It's worth noting too that there's lots of other sites in the North Island that are prioritised for control. They also have short and long-tailed bats, but there's not enough money to deliver that level of suppression currently. In the South Island, you can see that there's no lowland sites under sustained rat control unless they're in an area of the South Island which is where red beech is absent. So red beech is absent from here and this stuff down here. And so basically in these sites, we can deliver sustained rat control mostly because it's easy, but we are prepared to be there with 2 operations if things change. So we've got that built in. Outside of these forests, we're in upland sites, and the sites that were prioritised for sustained control are where rock green, orange-fronted kakariki, bats or mohua live. So the change here is basically sustained rat control is only prioritised to protect bats, kōkako, orange-fronted kakariki, rock green and mohua. Now, every operation has a row in a really exciting spreadsheet that we keep, and I had a picture of a spreadsheet here and everyone told me that they didn't want to look at it, so I've got a picture of a rock wren. I'd just like to point out that rock wrens have been marginalised in the kind of terms of this more birds in the bush. So next time I think we need to have more birds in and above the bush as the scope of the project, mostly because I'm quite fond of them. So in this boring spreadsheet, every operation has clear outcome and result targets. A result target is something like 21-night rat tracking never exceeds 5% in rock wren habitat. And an outcome target is something like the mean count of rock wren increases to more than 2 rock wrens per transect and is maintained. So those are the goals for the operation. There's also a whole lot of information about aerial treatment timings based on the prescriptions, and then triggering information, which is the most important bit. And this is so that operations happen at the right time with enough lead-in time to actually achieve the result and outcome targets. Finally, for each operation, there's a list of benefit and key species. Now, these benefit species are species that will actually benefit from the management that's been delivered at the site rather than every species that's at the site. So the outcome here is every site has clear outcome targets as well as a target pest abundance and how to achieve them. So now that we know where we're working, what we're protecting at each site and how we might go about it, it's reasonable to ask, well, it's all good in theory, but is it actually working? And before we can do that, I have to let you know about the monitoring network. So we've talked a lot about tracking tunnels over the last 3 days. And I'm happy to report that tracking tunnel surveys are back on. And they are at a resolution of 1 set per 10,000 hectares treated in the North Island and 1 set per 15,000 hectares treated in the South Island. Now this is a set of tracking tunnels here. It's obviously at Lake Alabaster, and it is 5 lines of 10 tunnels altitudinally stratified through the bush, and if it's got alpine tops above it, there's 4 lines of 5 going up the hill there. On top of this, there's also 3 acoustic recorders at these yellow dots in the middle of the bottom, middle and top lines, and also 3 trail cameras. Now the tracking tunnels are run before and after control operations, as well as set intervals between operations, which is 3 times per year. Now, this is a massive monitoring program, and as a result of a lot of new North Island sites coming into the program for rat and stoat control, we've had a big job setting up tracking tunnels in the North Island. A lot of these blocks didn't have any monitoring in place. The South Island, however, is pretty well set up and the data's rolling in nicely. So currently we've got about 12,000 tracking tunnels run 3 times a year. And when we're finished setting up the North Island, it'll be about 15,000 tracking tunnels with 700 trail cameras and 700 acoustic recorders. So this network will give us some great information, which I'll get onto soon, but it's worth acknowledging that the network doesn't measure everything. Frogs, theo, rock wren, and plants like mistletoe need their own more detailed outcome monitoring, as they don't tend to show up on acoustic recorders.
And snails.
Oh, and snails. Sorry, Graham. I got the picture. We also need to learn a bit more about the management of our new prescriptions for some species. For example, bats and frogs. For bats, it's pretty simple. It's scaling up our existing monitoring, but for frogs, it needs to be additional standalone monitoring. Now, this is where things start to get pretty exciting, as we're starting to build a picture of how our management is affecting other pest species. I'm going to run through some preliminary results, but it's not as interesting as it could be yet, as we haven't installed the non-treatment sets. But hopefully this will give you an idea of the kind of analyses we can do in future, as well as areas for future research calibrating camera indices with density and conservation outcomes. So first up, we've got some kitty cats. We've got mustelids popping up on trail cameras, and we've got some work this year to calibrate that against our existing indices. What's really exciting about mustelids is we now have the ability to tell them apart, which we didn't used to on tracking tunnels. We get things like deer, goats, and pigs. And I also wish I had prepared a slide on the other hogs now too, but I hadn't done it, so sorry about that. This pig here is quite cute. He decided to have a sleep next to the bait. So the change here for the program is we've got integrated result and outcome monitoring in treated and untreated areas. And the outcomes of that is we have broad scale monitoring of outcomes for birds and bats, and also we have trail camera indices for poorly understood pet species. So now some results. Here's a, well, actually, first off, I was actually going to show you guys a bunch of charts, but it's getting pretty late in the day and we've been sitting on our butts for 2 days and I thought attention spans might be falling. So this is a summary of the kill rates from the 2023 mass response, where we managed to get all the new timings off the ground. And my colleagues told me that this was too boring too, so we'll just go with this, which is basically we've delivered 5 operations in the food glut, unfortunately. A couple of them were a bit late off the ground with the new timing, but we decided to go ahead anyway. And we got an average kill rate of 83.8, which is not great, and an average kill rate for mice is 71. Now, when we delivered operations when we intend to from now on, there was 12 of them. The rat kill rate was 99.8%. And the mouse kill rate, which is possibly the most exciting thing, is 94.4%. So we're finally getting some consistent high mouse kills, which is quite exciting now, especially as Josh has sort of outlined the secondary poisoning potential for that. So outcomes for that is reliable mouse kills and reliable rat kills. And hopefully an outcome of that might be more birds in the bush. So that's the end of my talk. It's a bit of a wait and see about how all this new thinking and prescriptions is going, but the preliminary results are looking pretty good, and we're set up to be able to measure some cool stuff going forward. Thanks.
Thanks so much, Tristan. That was excellent, and yeah, a really lovely summary at the end of our 2 days. So you've got a couple of questions, and we've got a bit of time, and so I think what we'll do is ask them of you now, and then I think I might hand straight over to Adrian, and we'll wrap up. We were going to have a 5-minute break, but you've been so efficient with time that I think we're going to carry on straight through. So let me ask you some of these questions that have been coming in.
Okay, I'm going to drag these other two in because they're meant to help me with this. So you can ask all of us
Cool.
together.
Okay. Right. So I'll start at the top because maybe I should start at the bottom. No, I'll start at the bottom because they're keeping on coming in. And so please do keep them coming in and we'll try and get them all done. So Deb's, no, I've asked Deb's. Nathan Whitmore asks, Tristan, there's obviously high dependency on the validity of delta T models for management, but delta T is good but not great, even for beach, right? What, if anything, is being done to deliver an improved predicted masting model for beach?
I think you can answer
Okay,
that.
yeah, well, we've got a new model which addresses the individual beach species, and that's and incorporates a bit more information than we had in the old delta T model. There's more parameters in the model, so it does a better job of higher R square than it used to have. So it'll be a bit better, but I still suspect, Nathan, that our beach prediction models are still going to be really very good when it predicts no seeding, and really very good when they predict heaps of seeding. But I think in the middle ground, it's always going to be problematic, and I don't think there's any solution. In a kind of way, our new model, our new timing prescriptions for 1080 make it not so much of a crisis. What it means we'll do is we might end up running some nip it in the bud operations because of a beach mass prediction, and we'll end up doing it when it won't have been necessary. But except that's a financial crisis, but not a biodiversity one. And I think that's all I can say on that.
Thank you, Graham.
I could chime in there too, is there's also some of our colleagues are working on a REMU model at the moment, which is a big gap that needs filling. So that's the Kakapo team, because they've got quite good data on that. So
And Adrian will be producing a model for us any day now as well.
maybe they could talk to each other.
Yeah.
Great to hear. Kerry Weston asked, Graham, did this shift in timing of 1080 operations utilize or build on any of the findings of the work by Rochelle Binney in 2018, optimal control of erupting pest populations in a climate-driven ecosystem?
Well, I can't remember off the top of my head what Rachel recommended we do, so I can't answer that question. But yeah, we'd all read the stuff, so I imagine it did.
Thank you, Graham. Joe Carpenter asks, hi, Tristan. Do you know what work is going on to calibrate camera indices against density for those other pest species like stoats? So density again.
Yeah, so there's no work on density. We've got a bit of money over the next year to calibrate the trail cameras with existing indices. And the reason we've chosen to do that over density is we've got all these kind of, I'll call them density impact functions, but it's the worst term to use. But like we know that, for example, if we want to have healthy populations in mistletoe, we need between 2 and 4% RTC. And like we know for rock greens that stoat checking has to be below X, and for kiwi recruitment, similar things. And so we've got all these I guess outcome studies that are tied to these indices that aren't necessarily tied to density, but because we want to be more focused on outcomes, that seems like the best thing to tick off first.
Thanks, Tristan. Okay. Haojin Tan asks, Tristan, intriguing presentation and awesome work gone into informing the different sites across the country with key species and ecosystems, which is allowing you to prioritize. Seeing that we also have projects across the country led by others, would you consider sharing this information and knowledge with other predator control initiatives to boost efforts and impacts collectively in a coordinated way? Apologies if this question has been asked before.
Yeah, good question. I can't see any reason why we can't share this kind of stuff. Like it's all, yeah, the more the merrier. So, yeah.
Great, thank you.
Mm.
John Innes has just asked another question of Graham. where is a good place to go for a virtual beer after a virtual conference? Don't answer that.
He doesn't drink beer, so.
Yeah. I can have a virtual one.
All right.
I think we have
That
a
too.
question from Robert Shadowwinkle again. I remember that some pen studies showed that mice can detect 1080 in bait formulation. Do you think mice eat the bait despite that because they're hungry outside the food glut?
Yeah, this one's for me. Yeah, I think the interpretation that mice can detect 1080 is right, but the question is, how are they detecting it? And if you really drill into the study that the lab study that was done, which concluded that, it really looks to me like they detect 1080 by eating some and feeling sick, not because they taste it or smell it or anything like that. And so I think by and large the chemists claim that 1080 is largely tasteless and odorless, and that any tastes and odors are actually from impurities in the manufacture process is probably true. And so it's just that mice tend to get sick more easily, perhaps from eating smaller amounts, and so they detect it more readily, as the reason why we've struggled to get kills, and also the bait encounter issue with mice with smaller home ranges. So I don't think that there's actually strong evidence that mice can actually smell or taste 1080 any better than rats.
I've always had this pet gripe anyway, that if a mouse came along and ate a bait and it tasted a little bit off, a little bit strange and novel, that is just the normal process for any animal that eats a variety of food, that it has to try novel bait. So it eats a little bit of the novel bait and it doesn't go, ooh, I can taste 1080, I'm not going to eat any more of that. It then waits and it either gets sick or it doesn't get sick. So presumably if it didn't get sick, it would say, that tastes okay, it's a safe taste, I'll go back and eating some more. So surely that mechanism always got to be, it's not because they taste 1080 or they read the label and see it's got 1080. It's rather that they go, ooh, I'm feeling a bit crook now.
Sick.
Yeah.
And I guess we think the reason that the mouse kill rates are up and now predictable or predictably good in that post-germination phase is the mice are starving, and so presumably they're desperate and eating more than a cautious amount. That's how the mechanism works in my mind. Is that how do you see it, Josh?
Yeah, I think there's nothing else in their tummies. They're not sort of mixing up their meals, and they're hungry and down tuning their novel food testing regime. It's probably some combination of the two. Nothing's ever explained by one mechanism in my experience.
And I can't remember the name of the paper, but Susan sent us a paper last week, which was a lab trial, which kind of supported this concept, didn't it? Can you remember the name, Susan?
I can remember it said that mice eat more bait when they're hungry.
Yeah.
Yeah.
Background food levels influence encounter rates and acceptance.
There you go, Josh.
Paper.
Yeah, and I thought that would be quite, given that your strategy is very much based around that sort of thing now. So fantastic. We've got one more question. Graham or Tristan, I understand that the reasoning and logic to doing late summer, autumn 1080 ops. However, what if you lose the birds you're trying to protect over the preceding months?
Yeah. Well,
that's Joe Tilson. Thanks, Joe.
Yeah. Well, I suppose we're all thinking we really want to avoid these times when it doesn't work very well. But there's always going to be the situation where it comes up where the best choice is going to be to do a 1080 operation that may not be very effective. So I take Joe's point exactly. You can't leave your 1080 operation till February if you think they're going to be extinct before February. So yeah, hopefully we're fleet of foot enough to be able to be adaptive to deal with those situations. But at some of the key sites anyway, we hope we will have done a nip it in the bud operation. So that should deal with that. It's just at those sites where we've decided, well, even at those sites where we've decided only to do one operation and we think it'll mostly be a post-germination operation, we've kind of built into our thinking that when there's a crisis on, we'll try and deliver a nip it in the bud operation at those sites as well. We're thinking exactly the same as Joe is.
It's sort of a bit of a you're trying to make the least bad decision all the time, is because we don't have the money to do the best control everywhere. So it's a bit of a, yeah, it's not very nice.
Yeah, the best control everywhere would just simply be in any masting site, you just do 1080 operations, but that means our program would probably reduce by about 30% or something if we did that. So
Yeah, and we'd lose a whole lot of species from a whole lot of sites. So
juggling game.
yeah.
Well, Josh, you looked like you were going to add something.
Oh, did I? God, you can read me so well, Susan. Yeah, I think the main difference is that in sites where we're never prepared to do the nip it in the bud and the follow-up, we're not saying we're trying to hang on to rat-sensitive species anymore. So we've said if we can't afford to do that everywhere, so we're not claiming to do it if we're not prepared to deal with a high magnitude or an oncoming high magnitude eruption with a nip it in the bud.
And some of you might have seen in the past, like often there'll be like a possum operation, which is once every 6 years, and the messaging around it will be, it's to protect long-tail bats. And so we're just trying to get everyone on board that that's not what we're protecting. We're there for possum values, and although they're there, that's not the primary reason for being there.
Right. And one more question has snuck in. Craig Morley asks, is there any research on other alternatives to 1080? Kill mice and rats. I imagine it's to kill rats and mice.
There's a bit of chat about, is it diphencyline?
Double tap and things like, yeah, but they're not exactly new poisons. They're sort of already around and people are just exploring their use. You're probably asking the wrong people. New poisons is probably a topic for chemists more than us.
There is work on, as Josh talked about, new methods for killing carnivores, but yeah, it's on the radar, but we're not exploring it at present.
I mean, I always hope that there's going to be biotechnological advancements that are going to assist in this kind of field, but I'm never sure that the level of investment is there to actually hope that something's going to come soon. I believe it's going to be a big corner, like what was the other big corner? AI for birdsong.
Right, just around it, yeah.
Well, thank you very, very much for all that thinking and for presenting it to us and answering all those questions. Yeah, it's been super interesting and super informative.